Hello, everyone. Good morning, respected authors and invited guests. Welcome to the technical session 5E. Myself, Gayatri Burguda, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you to the 10th International Conference on Smart Trends in Computing and Communications, SMARTCOM 2026, Pune, India. The 10th edition of the conference is being organized in a hybrid mode. The physical event is held today in Pune, India, and the virtual event is being held through Zoom from 19th to 21st January 2026. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentations and 2 minutes for question and answers. Upon 9 minutes, I will raise a gentle reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we start the session, I would like to introduce you all to the chair for this session. Dr. Neha Tiwari is working as an associate professor and R&D coordinator at Institute of Advanced Computing, Sage University, Indore, India. She is a research supervisor with an experience of more than 16 years and has also supervised the students in a variety of projects. Her research domains include networking, machine learning, blockchain, databases, software engineering, and cloud computing. Ma'am, would you like to address the participants?
Yes, ma'am. Thank you. Good afternoon, everyone. So it is my great pleasure to welcome you all to this session at SmartCom 2026. Ma'am, am I audible to you and everyone?
Yes, ma'am, you are audible.
Okay, ma'am. Thank you. As a session chair, I am honored to be a part of this esteemed gathering of researchers and professionals. This conference serves as a vital platform for exchanging ideas, discussing groundbreaking research, and fostering collaborations that can derive innovations in our field. Particular our field, the session ahead promises to be both insightful and inspiring with distinguished speaker who will share their expertise and latest findings. Before we begin, I would like to extend my gratitude to the organizers, sponsors, and everyone involved in making this conference a success. I encourage everyone to participate actively, ask questions, share thoughts, and take full advantage of this opportunity to learn from one another. With that, let us begin. Thank you, and let us have a great session. Ma'am, please start. Yes, ma'am.
Yes, ma'am. Thank you so much for your kind words. Now, I'd like to start with the presenters. I would like to call upon our very first presenter, Sejal Dubey ma'am, with her paper titled An MCP Aware Cognitive Agent Framework for Secure and Verifiable Intent Encoding in Video Content Services Provisioning. Over to you, Sejal ma'am.
Hello, ma'am. Am I audible?
Yes, you're audible, and you can share the screen and start presenting.
So, good afternoon to all the members present. I'm Sejal Dubey. I'm from Department of AML from Symbiosis Institute of Technology, and I'm going to represent this paper ID 780 titled MCP Aware Cognitive Agent Framework for Secure and Verifiable Intent Encoding in Video Content Service Provisioning. This is a collaborative research work along with my colleague Samriddhi and Veer under the guidance of Dr. Archana Chaudhary ma'am and Dr. Puneet Bakshi sir from CDAC. So the main problem which we addressed through this paper was that the model digital services follow a fixed subscription plan, where, for example, I as a user, if I want a low or a medium level video according to my budget, but I still have to pay the same amount as with someone who is utilizing the services at a 4K. So to address this, our solution could build such systems which could understand what is the intent of the user, then matching the user intent with the service provider. So the user could get the facility from the service provider. And thirdly, a fair billing can be ensured, where the user just have to pay for the services which he or she has utilized. So coming to the research objectives, as mentioned, intent understanding is very much important because catering the services based on users' needs is very important for the service providers. And we have tried to cover the intent understanding part as well. Coming to the cryptographic security, as we know, ensuring non-repudiation throughout the process is very much necessary so that a user cannot deny that he or she has not taken the service, and a service provider cannot deny that he or she has given the services. Then a fair billing model, where pay per use model has been designed, where the user could only pay for the services which he or she has enrolled for. And we also went to different literature reviews where we went through different papers and identified the three most important gaps. First is lack of low latency LLM architectures. The existing LLM architectures which are there in the market, they are very heavy and not resource useful. For example, for such applications, for real-time applications, we need LLMs which which have a low latency. So that was one of the gaps which we identified. Then second is missing secure intent to billing link. So as I mentioned, connecting the billing to what the user has actually taken from the service provider is very much necessary. Then coming to the cryptography part, where need for performance tolerant cryptography. So the existing security standards, they follow a policy based system where the user might have to wait for a longer time. But when we uh, utilize a cryptographic way of addressing this problem, the waiting time for the user gets reduced. So these are the three gaps which we have identified. Then coming to the proposed system architecture named as secure stream that we have proposed. So let me walk you through the data flow. Firstly, the user will request what he or she has to get from the service provider. For example, I want to watch a medium quality video in this much latency. So this request will get processed through this intent extraction part, where the actual request will be processed and a JSON file will gets created. So this is the MCP aware secure intent process, where the model understands the context of the user and follows a protocol which has been set by us. For example, it will extract all those specific parameters of the latency and the network, and then the extracted intent will be passed on through the uh, for further process, where it will be converted as a vector. And meanwhile, in side by side, it will also get digitally signed to ensure non-repudiation, and it gets stored here. So as I mentioned, a vector gets created of the query which the user has requested, and then we have a database of the service providers which has all the services they have to provide, and we also have a vector of the service provider. So using a cosine similarity, we take out the similarity of the user vector and the service provide vector, and then we match it, and we give a list of service providers to the end user. So the user could choose which of the services aligns with his or her needs. And this also gets digitally signed to ensure non-repudiation, and then a bill gets generated which is shown to the end user. So the dynamic billing part also gets covered through this process. So we built the prototype using the following tech stack, where for the LLMs we utilized Llama 3.2 model. Why Llama 3.2 model? Because it is a lightweight model, and for the real-time application, we choose a lightweight model along with doing a few short prompt engineering. Then For the backend, we utilized Flask with SQL. And for cryptography, we utilized the standard library for RSA PSS. PSS is the probabilistic signature scheme where for example, in RSA, the regular RSA follows for example, I give the data to RSA and it generates the same signature. But there is a possibility of a vulnerability where for two requests from the two different users would generate a same signature, which might uh, be a possibility of vulnerability. So we choose the RSA PSS because through RSA PSS, we are adding a noise with the data which we give to the RSA, and for for same request from two different users will generate two unique representations. So for that we use this, and for front end we use the regular front end of HTML, CSS, JavaScript for building the UI, and we tested on NVIDIA GTX 1650 GPU. Coming to the performance evaluation, this is the radar chart. So for performance, we focused on accuracy and speed. These two factors. For accuracy, we plotted the three parts of the LLM: one shot, few shot, and zero shot. And as we can see, the areas covered by the blue line is higher than the red one and the green one, which shows that the 70% accuracy is of the few shot. So we prioritize accuracy over speed because providing the right content is very much necessary than providing the faster content. Then coming to the execution time, we calculated the total execution time while processing the user intent. But as we can see, the average execution time and total execution time are not much as expected. But this in itself becomes an area of scope which we are already planning to improve. And so project outcome is an application which could understand the user needs and cater the services accordingly. So these are the features which I explained. So concluding the project work is that we used a lightweight LLM. We also utilized asymmetric cryptography and pay-per-use model we built. And in future scope, we are planning to scale it up to cloud native architecture where we could scale it up for thousands of users, and we are also going to address the execution time problem which we faced in the results. So thank you so much for giving me this opportunity for explaining, and I am open to any questions.
Ma'am, would you like to ask any questions?
Yeah, yes, ma'am. Very nice, Sejal. Your model is very good. So, can you please explain again about your existing research? Which type of research keep you have find?
Uh, Sorry, ma'am. If I'm clear, you are asking what type of research papers I went through.
Yes, yes, yes.
Okay. So, ma'am, there is not such a single paper which covers all three aspects for like the LLM part, the cryptography part, and the content management services. So these are the three major areas, and we went through different papers to understand the different drawbacks. For example, the LLM part, like there are existing LLMs which are much more faster than Llama model, but for real-time application, a lightweight LLM is very much necessary. Then secondly, cryptography. So existing solutions suggest that we can also use blockchain, but using blockchain does not guarantees a faster processing because as we know, blockchain takes more time for the verification part, but through cryptography, it is done, it takes milliseconds. So, and we also calculated the time, and it was some 0.395 milliseconds. And thirdly, the content management services. So as we know, existing systems like Netflix, we just pay for a 1 month and whatever content we can watch. But
Right.
different different users when who can't afford, or like who just want a low or a medium quality video for a few hours, so they can utilize these services. So that was the thinking which we planned our work through. Like we kept that
Okay,
in.
right.
Yes, ma'am.
Okay, good. So, which GPU is used in NVIDIA? I
Sorry,
think
ma'am.
once.
Once,
Which type? Yes, and in NVIDIA software model you used now for hardware.
yes, ma'am. That means we tried to show that it can work on a regular system. It doesn't
Regular.
need more intensive.
So
Yes.
you have you tried in another GPU also in NVIDIA?
No, ma'am. We have not tried in another
Okay.
GPU, but we can look into that, like trying on
Yes.
different systems.
Yes,
Yes,
you
ma'am.
can try. Okay.
Yes.
Okay. Thank you.
Thank you, ma'am.
So, ma'am, can I ask something?
Yes.
Yes, sir.
Yes, sure.
जी, thank you, thank you. So, like, I just wanted to ask, पहली बात तो
Yes,
congratulations
sir.
on your work. So, I just
Thank you.
wanted to ask that, जी, so like, what you're trying to do is, you want to provide different services, quality of services to different users, and as per the
Yes.
quality of services, you'll take the charges, as in they'll pay differently, right? This is
Yes,
what I
sir.
understand. What is the learning part, and kindly focus on, because there are three components, right?
Yes,
So
sir.
you have got some accuracy. So
Yes,
can
sir.
you please focus on the loss function, the loss curves, and the learning part? As in, what are you trying to learn? How, what is your exact model of learning? So can you please focus on that? The performance measures and the loss functions of that learning part.
Okay, so coming to the learning part of the model, so we used
Mm.
Llama model, which has 3.5 billion parameters. First, we like we three there are three ways: zero shot, one shot, and few shot. And like we gave it different types of prompts, and we analyzed that of the few shot gave more accuracy than the two different methods which we so our learning part was that the model shows the accuracy increased from zero shot to few shot. uh, I mean 70% accuracy it achieved. So it shows a scope of improvement that more we can fine tune the model based on the data set. As for this application we used a movie API database, but the application the database may differ from application to application. For the proof of concept we
Hmm.
took the database, and we tried the few shot, one shot, and zero shot on it, and it still gave results. Like we can improve it and fine tune the model based on the database provided.
Okay, चलिए मतलब have you used movie database to train your model?
Yes, sir, because we just wanted, because video might differ from the organization which have to use our application. For example, like for educational videos we can fine tune our model on
Well,
that data
which is
set.
amazing.
And
मतलब were you able to learn from the videos?
y- sorry, sir.
It's a huge data. Doesn't make any difference. ठीक है. I got your point. It's actually a very huge data. It requires a lot of. Any case, ठीक है. You must have done good. Thank you.
Yes, sir.
Thank you for your presentation, ma'am. I would like to call upon the next presenter now, uh, Shobha K. ma'am, to present her paper titled Lead Guide, an Intelligent Chrome Extension for Assisted Problem Solving on Lead Code. Over to you, ma'am.
Thank you, ma'am. Hope I'm audible.
Yes, you're audible. You can share the screen and start
Yes,
presenting.
yes. Uh, since I'm like quite in low network zone, I tried connecting my video, but I don't think it's possible. Anyhow, like I'll try connecting in the middle. Good afternoon, everyone. It's myself, Dr. Shobha. I'm assistant professor in Siddhganga Institute of Technology in the Department of CSE. Today, I'm going to present the work that's Lead Guide, an intelligent Chrome extension for assisted problem solving on Lead Code. A few terms that are there in the title of the paper. It seems like, yeah, we have heard it somewhere. Yes, it is our day-to-day life. We are trying to use it to practice the programming context that have been there. It is similar to the hacker rag, hacker and all those things that have been there. So the Lead Code is one such platform where we are trying to improvise on the Lead Code platform, or we are providing to the main aim of the work is to give the AI assistant related to that. So the main thing that we are trying to look into is, as we know, the technical interview preparation is very critical, often relying on the platforms like Lead Code, HackerRack, and DuckDuckGo. The main problem that we are trying to face on this is platforms lack interactive or context-aware guidance when user gets stuck. So what we do is, whenever I get stuck with it, mainly I copy the problem statement and try to find in the Google, or I can ask the Claude, or I can ask the Chat GPT, all such things. That there is no inbuilt AI support that has been there in case of the Lead Code. Current behavior of the students or the programmers is very much related to the students switch tabs to forums or videos, breaking concentration and often finding full solution rather than the hints that might lead to the loss of their interest, or the situation could end up in such a way that they might lose the interest while coding once they get into entire solution. So our main solution is Lead Guide, a Chrome extension that is going to get integrated with Gemini AI directly into the browser for the real-time assistance. That is what the entire work is focused upon. So the problems that we are disrupted workflow that has been there, that is switching the tabs to find out the solution, or unable to find the entire what is the right solution. All those things is a problem that has been there that could lead to the disrupted workflow, or it might end up in, for the learners to, it might end up in the passive learning. That is, discussion forums often provide the direct answers that may lead to the memorization rather than the understanding that has been there, and the lack of context that has been there. So external tools doesn't support or doesn't know the specific problem or the user's current code state that has been there. So the solution that we are providing into that is integrated support that very specifically on the Lead Code page. And then context aware AI that we are trying to bring in with the help of the Google's Gemini AI to read the problem statement and use the code automatically. And mentor approach that we are trying to provide hints rather than giving the entire solution. We are trying to bring the hints and logic explanation rather than just the code snippets that are being there. Each code will be having, we are trying to come up with like why this particular line code, a detailed explanation related to the code that we are trying to do. So overall workflow that we, our main aims and objective is integration. We are trying to integrate the Gemini API, AI with the Lead Code via seamless
Ma'am,
Chrome.
your slide is stuck on the first slide, so can you please try to share
Uh,
it again?
okay, sure. One second, ma'am. One second.
Yeah.
Ma'am, is it now, is the aims and objective visible?
Ma'am, your screen is not visible.
Uh, One second.
Yes, it's visible right now. You can continue.
Yeah. So the main objective here is to integrate the Gemini AI with the Lead Code via seamless Chrome extensions, and then we are trying to bring the context awareness automatically. We are trying to. It's not. We are not looking to copy paste anything. What we are trying to look is automatically extract the problem description to tell AI responses that are being there, and then what we are trying to look is simplify the workflows that are being there, and then provide on-page chat support to eliminate the tab switching, and we ensure the data privacy by since we need the API key for this, so we are trying to store it locally in the browsers. So coming to the literature survey, no such single literature survey is existing wherein someone is trying to look on page support that has been there. So we have, since we have went through the different LNM models, or we are trying to look into the different prompts that we are trying to generate, so we have went through the literature survey in that particular aspects, and in terms of the cross domain supports that we are trying to look into. And this is the hardware and software support that we are trying to look in. So software stack is mainly, we can work on any of the OS that has been there, and mainly this, as of now, we have built in terms of the Chrome extension. And languages that we have tried to use is the HTML, CSS, and the JavaScript for the communication, and the API that we are trying to look as the Google Gemini API. So this is the entire workflow that has been there. User will be able to log into his lead code page, and then we have designed the different models that have been there. That is the pop-up JS, where API key input and the validation, as we have to validate the corresponding user. So we have used that particular pop-up JS, and then the content JS. So it is going to inject the chart UI. So what is the problem statement? We are trying to look into the what problem statement or what stage the user has stuck in. And background JS, where it is trying to look into the manage the permissions, or it is trying to what would be the next event, all those things, or it tried to orchestrate the communication between the lead code and the user that has been there. And whatever the workflow that has been there, that is we are trying to look in the first layer. Later all these things collectively will be given to the Gemini API, so that it can get into the solution, that is that part of solution we can able to retrieve in that particular case. And then we have used the inject.js, where to interface the Monaco editor. We are trying to inline our interface of the AI or the chatbot with inline with the lead code interface, so that we are trying to use with the inject.js, and the chatbot CS, that is for the styling that we are trying to use. And this Chrome local storage, as I said, we are trying to provide the security as of now by storing it locally with the browser saving part. We could able to achieve the security part, and we are trying to get the AI response rendered through the injected chatbot UI. This is the overall architecture of the proposed model that has been there. So we have pop-up model, as I said, it is entry point for the user, mainly to secure input and save the Gemini API key. That's the initial phase that we are trying to use. Apart from this, background services that we are trying to have is acts as a bridge, listens for the messages, and manages the asynchronous response that has been there. Any intermediate stage of services, we could able to get that. And the
Hello, ma'am. Sorry to
yes,
interrupt you, but
um,
your slide is stuck on aims and
oh,
objectives still.
once again, I'll try to reshare it, ma'am.
Yes, ma'am.
Sorry for the.
No, ma'am, it's okay. Try again. Ma'am, please click on slide share.
And that only I've done, ma'am. Probably because of I'm quite a low network area. Probably that's the reason that I'm not able to get it in the right way.
But it's not on slideshow. It's in another format.
Yeah, that is because I have used the WPS office, maybe for
Yes,
that
ma'am,
reason.
but start from slideshow.
Just a minute, ma'am. Just a minute. Yeah. Now, and the current slide I'm showing is the implementation details, ma'am.
Yes, ma'am.
Yeah. And then the what we are looking into, the other aspect is the content script, where that injects the ASCII. How the things work is, if I feel stuck at some point of time, immediately what I do is there will be ASCII button in my chatbot. So it has the ASCII button. So if I just click the ASCII button, so which point of time, I mean, like, it will read what is the content that has been already there, and that point of time we could able to pick the content, so that it could able to suggest from that point, as that point of time. So it scrapes the problem title or description and extract user code from the editor of the lead code that has been there. So these are all some of the tests that we have went through, that is API key input, so accepts and securely stores the Gemini API key, and chat interface that we are trying to look as, that is toggle visibility via a ASCII button. This we went through just to check on what is the time that we are trying to look, corresponding to just copying paste and just the inbuilt chat interface when it comes to the ChatGPT. And the context extraction correctly detects the problem titles and the description, whether what is there on the lead code page and what we try to able to extract, whether it is right or wrong. And the AI response sends query to the Gemini and display the formatted answer, what it from that point of time, what is the answer that we are trying to. And as I said, it is not the entire solution that we try to begin, it is the hint that we are trying to give. And then only if the user could able to see wants the entire solution, then only we are trying to provide the entire solution that has been there. So just to have compare our work with how good it is compared to the manual method and the proposed method. So we went through the comparison of the manual method versus the lead guide method. So successfully, in case of the manual method, where the entire solution will be given, it took 12 seconds of the time to get the solution of the different complexity. As we know, many of the platforms supports low, medium and high level of the complexity. So this is what, with the different cases, we could able to achieve the 12 seconds as well as the 4 second. So manual workflow, what is the things that is, then we have to copy the problem, we have to switch the tab, or you have to search or paste the corresponding data and the filter the results, because as we know, there will be n number of results that will be coming out. And in case of the lead guide workflow, it is just one click, that is ask AI. If I try to do, then the auto context extraction will be happening and the instant response will be given by that time. Then why specifically Gemini API when
Hello, ma'am.
yes, ma'am.
Ma'am, you've reached the 9-minute mark, so can you
Okay.
please speed up the presentation?
Sure, sure. We
Yeah,
are
thank you,
almost
ma'am.
watching. Okay. So why Gemini APR? Because if it's a superior latency that has been there, when we compared our method with the Gemini Flash light response, it took 1.25 seconds, whereas GPT-4 took 3 seconds and the Claude took 4 seconds. And the cost efficiency, it offers generous free tire. Making it suitable for students projects compared to the expensive alternatives, and use context winner. There are so many token context allows processing large code bases and the lengthy problem, and it's quite easy compared to the like when it comes to the platform integrations that has been there. So as a part of the future work, we are trying to enhance it to the multi-platform, and then we are trying to assist with the voice interaction, so that any people who are interested in coding, so they could be able to get it. And as of now, we are not storing the session histories. Whenever we solve some 10 problems, all the 10 problem session histories are not there. So we are planning to store the session histories, and we are trying to have the adaptive learning, that is tailor in difficulty based on user performance over time. That is what we are trying to look it for. So as a conclusion, lead guide successfully it going to transform lead code into an interactive AI driven learning platform, mainly focusing on the learning and the scalability to reduce the context switching and keep students in coding zone. It promotes learning and understanding through the mental styles hints over rote memorization. So we can scale it with the modular architecture, where it allows for the easy addition for the future features that are being there. So these are the different references that we have went through. And thank you, and sorry for all the inconvenience that happened in the middle of the presentation. I'm open for the questions.
Hello, ma'am. Congratulations for your work. Nice
Thank you,
model
ma'am.
you have designed.
Thank you,
So,
ma'am.
could you please explain again your model?
Ma'am, what we are trying to look into that is rather than, as we know, whenever we don't get the particular solution, what we are trying to do is we copy paste the entire problem statement. And when we search in Google or any of the other models that have been there, we are trying to get the entire solution. So, what will the students will able to do? Students get distracted when the learning gets lower when the students could able to get the entire solution. So, rather than that, we have trying to build the I mean, like in the page of lead code itself we are trying to build the chat bot where whenever the user stuck, if he presses the ask AI button, we could able to read what till what point of time the student has done it. From that particular point we could able to help the student in the incremental way, not in the entire solution at once. We are able to provide it at the incremental way. We are trying to help, we are not giving the entire solution. We could tell like add the loop at this stage, or perform the add some searching statement, or some sort of hint based on the solution we are trying to give the suggestion for the student.
Okay. So is it implemented fully?
Yes, I mean, like, no, not, I mean, part of the work is implemented.
Part of
We
the
could
work,
able to,
yes.
yeah, because we could do it only for the lead code, where the low and medium level problem statement. Still, we are working on the complex level problems that are there.
Okay. So in the research paper, you are presenting or you are writing a part of modules,
No,
not
not really,
complete.
not like that. But since whatever the work we could able to get the successful part, we are doing that things.
Okay. Okay, ma'am. Thank you.
Thank you, ma'am.
Thank you, ma'am, for your presentation.
Thank you.
I would like to call upon the next presenter, Neha Makattal, ma'am, to present her paper titled "A Multimodal Review for Real-Time Violence Detection and Multimedia Data." Over to you, ma'am.
Yes, ma'am. Thank you. I'll just share the screen.
Yeah, sure.
Ma'am, am I audible? Hello. Ma'am, I hope I'm audible.
Yes, you're audible and the screen is visible. You can start.
Uh, okay, good afternoon, everyone. Thank you for being here. My name is Neha Makatil, and I'm currently presenting this research on behalf of our team, Vanita Mane and Tushar Ghurpade from Department of Computer Engineering at DY Patil deemed to be University in Navi Mumbai. Our paper is titled A Multimodal Review for Real-Time Violence Detection in Multimedia Data. Today, I'll walk you through a comprehensive review of 5 deep learning approaches for automated violence detection in surveillance system and share our experimental findings on which approach works best for real-world deployment. Let me start with why. What does this matter? For the first challenge, a manual monitoring of continuous surveillance footage is impractical. Now, if you think about it, a single CCTV camera records 24 hours a day, 365 days a year. A security guard cannot watch it all. That's thousands of hours of footage. For the scale, thousands of cameras are now deployed in public places like airports, train stations, streets, malls, etc. They generate massive video volumes every single day. Handling this manually is near to impossible. Now, real time detection is critical. If violence is happening right now, security personnel needs to know right now, not after reviewing the footage. That's where the difference between preventing an incident and documenting it comes. And finally, the impact. Automated systems can really save lives in public spaces, institutional spaces, or airports. The ability to detect violence automatically can alert security in seconds. Now, this is the problem that we are solving. Uh, to move forward with this, we reviewed 5 different model families used in recent deep learning researches. First is the AI/ML approach. These use hand design features like optical flow, motion histograms, and edge detection. They're quick to adopt when we have new data, but they achieve only 92% accuracy and take 150 milliseconds per frame. That's relatively slow for live processing. Next, we have the X3D with optical flow. These are spatiotemporal models. They understand both space, like where the things are, and time, how they move. They reach 96.5% accuracy at 35 milliseconds. That's better, but they require powerful GPUs. Uh, Third, we have ResNet 3D architectures. These use residual connections. They also hit 96.5% accuracy, but at 60 milliseconds per frame and with a very high memory consumption, which is not ideal for edge devices. Now, fourth, we have the MobileNet V2. This is an edge-optimized device model, meaning it's designed for deployment for resource-constrained devices like cameras. Despite being lightweight, it achieves 97.5% accuracy in just 28 milliseconds. For next, we have the CNN LSTM hybrids. The LSTM captures temporal dependencies. It remembers the sequences of frames. It achieves 96% accuracy, but at 120 milliseconds per frame. It's the slowest, that's over 4 times slower than MobileNet V2. Now, it depends on which one is the best. So moving forward to the comparison, here's the trade-off visualized. This chart compares 5 approaches across 3 critical matrices. First, we have the accuracy. All models are clustered between 92% to 97.5% and accuracy. Now, the point to be noted is the latency. Now, looking at the range from AI/ML, which is at 150 milliseconds, all the way to a MobileNet V2, which is at 28 milliseconds, and CNN LSTM is at 120 milliseconds. For real-time surveillance on edge devices like Raspberry Pi cameras, embedded security systems, latency matters the most. A 120 millisecond delay means you process only 8 to 9 frames per second, and at 28 milliseconds, MobileNet V2 processes 35 plus frames per second. The third matrix is memory and computational cost. ResNet and X3D are very heavy. MobileNet V2 is by far the lightest. That's what mobile means. Depth-wise, separable convolutions reduce parameters by 40x compared to the standard convolutions. Now, let me break down the core insights from the literature review. For CNN LSTM models achieves near perfect 99% accuracy, which sounds amazing, but looking at the cost is 120 milliseconds per frame. For a security camera streaming 24/7, that is computationally expensive. It drains battery on mobile devices and it requires constant connectivity, which is not practical. Next is the MobileNet V2, which achieves a 97.5% accuracy in just 28 milliseconds. Now, the loss of 1.5% accuracy is there, but what we gain is the latency and the deployment feasibility. The model is small enough to run directly on the camera. No cloud is needed, no latency from sending the video to the server, and it's instant. When we think about it practically, we could rather take the delay in, we could rather take less accuracy, which is 97.5% for in real-time processing, rather than having 99% accuracy and more delay. Now, 28 milliseconds is 4.3 times faster than the CNN or LSTM models latency. In a 10-second video clip, we could process 150 more frames with MobileNet V2. That's more chances to catch violence as it happens. This is the paradigm shift with latency difference exceeds the accuracy gains for real-time deployment. There's another dimension to consider, which is the scalability. How do these models perform on new unseen footage that wasn't in the training data? For ResNet, 96 to 97% on new footage. It is very stable, but it requires 2 to 3x more memory than MobileNet V2. For a Raspberry Pi, ResNet won't even fit into it. X3D has a wider range, which is 90 to 97%. Because of optical flow, the algorithm that calculates motion between frames fails in certain conditions, like low light, fast movement, heavy occlusion. When the camera can't calculate flow properly, the accuracy drops to 90%. Now, for MobileNet V2, it shows 87 to 98% range. It is wider than ResNet, but in the actual experiment, our optimized MobileNet V2 achieved 97.5% on the benchmark, and more importantly, it only drops 3 to 5% on real world scenarios, which is better for generalization and heavier models.
Hello, Neha.
Yes,
I would like to remind you that 9 minutes are up, so can you please speed up your presentation?
yes, ma'am. Now, for the experiment, we did not just trust the literature, we implemented both MobileNet V2 and CNN LSTMs. The data set used was a benchmark violence data set with both crowded scenarios like fights, and the processing for processing, we extracted a 128 to 128 pixel resolution, which was normalized to zero mean and applied augmented. This teaches the model to recognize violence regardless of the angles or perspectives. We use a mini batch optimization with learning rate scheduler, which starts learning steps and then gradually reduces them as the training progresses. And both the models were trained with identical settings, with the same data sets and optimizations. No model had an advantage for the setup. For the experimental results, the MobileNet V2 achieves 82% accuracy more than CNN LSTM, which is at 76%. The MobileNet V2 has a precision of 83% versus 77% for CNN LSTM. And in real deployment for security center, false alarms can be a negative impact. So CNN LSTM would trigger alerts 23% of the time, whereas MobileNet V2 only triggers 17% of the time. So the win is that 40% faster training when MobileNet V2 trains. It reaches a convergence 40% faster than CNN LSTM on the same hardware. Now, for the training convergence, one more important term is scalability. MobileNet V2's training accuracy starts at 55% and reaches 72% by epochs. We can notice that only 3% training and validation are nearly identical, which means model is learning robust patterns, not memorizing the training data. For summarizing the key findings, we have a peak performance cluster. All five models achieve 96 to 99% accuracy. The critical real world gap is the latency, where these models on new data and new footage they have never seen before. The model was 99% accurate on training data and becomes 89 to 96% on real life footages. MobileNet V2 smaller drop in like a 3 to 5% drop for unseen footage was more preferable. Lighter models have fewer parameters, so they are less prone to overfitting. And the fourth finding is that the resource matters more marginally across gains. The difference between 96% and 97.5% accuracy is less, and the difference between 120 milliseconds to 128 milliseconds of latency is more uh, considered based on deployment feasibility. For the future directions, first we have the multimodal fusion. We are currently only using video visual information. While moving forward, will be implementing audio video multimodal videos that can consider both video as well as audio, which is more robust. And we plan to implement post plus mobile integration. For example, if we have the skeleton where people for the images, then it can be practically blocked by other person where the model struggles. Skeleton tracking adds a layer of understanding where it can see the skeleton if by the gestures and identify if violence is there. And third is we have verified MobileNet V2 fits in Raspberry Pi, but for real life deployment, it's not yet done. So testing on actual CCTV clusters in urban environments would be the next step. For the conclusion, MobileNet V2 is optimal choice for real-time violence detection in resource-constrained surveillance system. For 97.5% accuracy, we maintain a 20-second millisecond latency, which enables live deployment. In real time, it is the best model that can be used to integrate with camera models. In the surveillance industry, where we are moving forward from centralized server-based system to edge-based intelligence, this paper contributes to that shift. It shows that lightweight models don't mean sacrificing accuracy, it means gaining employment feasibility. Thank you for your attention. I'm happy to take questions.
Ma'am, do you have any questions?
No problem.
Ma'am,
Okay,
am I allowed to ask something?
Yes,
yeah,
sir.
Yes,
sure.
sir.
Oh, thank you. Thanks a lot. So, ma'am, first of all, nice work.
Thank you,
So,
sir.
if I'm not mistaken, you're working on video data.
Yes, sir.
So, ma'am, like because you've used CNNs, right?
Yes, sir.
CNNs to detect the body behavior, anger, whatever, है ना?
Yes, sir.
So, I had just two small doubts. First is that we also work on the video data. We have worked on depression detection. So the
Yes, sir.
point is that if we take frame by frame like pictures, it becomes extremely computational extensive and memory intensive work. So how
Yes,
did you
sir.
handle that? First point. And second point, if you could please go back to your training test accuracy wala jo, the curve that you showed, because you have, yeah, this one, right? Huh. So, earlier you said that all your models were having an accuracy of more than 90%. And here, there are two small things. First is that after the eighth epoch, you are reaching approximately 70% for the training part, and the validation, and for some reason, it is quite possible that you might have uh, pasted the wrong picture. But
Yes,
if I'm
sir.
not mistaken, the yellow line is not actually reaching the 70 wala portion as you stated in the slide. It is quite
Yes, sir.
possible that you by mistake have pasted the wrong picture.
Uh, to answer your question,
Ji, ji.
for the literature review here,
Hmm.
for all five models, I had considered five papers for each model. So,
Okay.
based on these five papers for each model, the research was done, and a CNN LSTM model
Right.
use
Got it.
paper was taken.
So CNN for extracting the picture, for extracting the information from the pictures,
Yeah.
and LSTM for the correlations between the different frames. Right. Huh.
Yes, sir. And
Ji.
then whatever the result was that was studied, and a MobileNet V2
Mhm.
was implemented on the same data set. that
जी जी जी
was used. And based on that, as for the review that we required, the mobile net V2 had a better
ये वो तो I
performance.
got your point. I exactly got your point. It was just a request to kindly just have a look at this slide
Yes,
because
sir.
the values
Yes,
that are
sir.
given here and the image are not mapping each other for some reason. It is quite possible that we might have missed something. Vijay, thanks a lot. Thank you. जी.
Yes, sir. Thank you for the question. I'll definitely look more into it.
Yeah, thank you for presenting. I'd like to
Thank you,
call
ma'am.
upon the next presenter. Berka Lixon, ma'am, to present her paper titled An Efficient Deep Learning Approach for EEG-Based Seizure Prediction. Over to you, ma'am.
Thank you. Hope am I audible?
Yes, you're audible. You can share your screen and start presenting.
Thank you. So good afternoon, everyone. My name is Baruch Alexan, and I am from Tezpur University. So our title of the work is an efficient deep learning approach for easy-based seizure prediction. So these are the contents that I will cover today. The objective of our work was to design a fast, efficient, and reliable convolutional neural network algorithm for detecting and predicting epileptic seizures, ensuring accurate real-time performance. So let's moving to the introduction part. We should know what is epileptic seizure. So seizure is the electrical disturbance that occurs in the brain, whereas epilepsy is a long-term neurological disorder. Epileptic seizure can be occurred by birth, it can be genetic, and by accidents or from brain injuries. And during an epileptic seizure, the person is seen having some jerking movement and can be senseless, and the person can fall anywhere. And for example, in a busy road, if seizure occurs, then the person can got harm and it can lead to death. And nowadays, over around 50 million people are living with disease, with this epileptic seizure disease. So it is very important for the people to get aware before it occurs and so that they can take precautions or treatment which will minimize the risks. And for recording the brain signals, we use electroencephalogram, and you can see the figures. A is showing the normal brain activity and B is showing the epileptic seizure activity. And the figure 3 is showing the phases of the seizure, that is interictal, preictal, ictal, and postictal. Interictal is the period before, that is the normal period without seizure, and preictal is the period before seizure, and ictal the period during seizure, and post-ictal is the period after the seizure. For literature review, the works on the epileptic seizure was started long decade ago, but we have shown here few works that is from 2021, and most of the methods were used to the CNN, and in the 2024 paper, STIT model, RNN model, and CSD methods were used. You can see the datasets here, CSV, MIT, and CNI scale datasets were used. And moving to the materials and methodology part, we have used two datasets here, CSV, MIT datasets, and CNI scalp easy dataset. And you can see the table here showing the number of data that is split into train and test and interictal and pre-ictal classes. And for CSV MIT data, the total datasets were 3,34,647. For CNI scalp, the total data were 88,265. And here for methodology, you can see the flow chart. First, we have taken the input easy signal, that is the datasets, and then we we have done the data preparation and then done the pre-processing steps. Then we have splitted the data into 80% train data and 20% test data. Then we have taken the 80% train data for model training, then the rest 20% data taken for data model evaluation, and for the easy classification. We have taken two classes, that is interictal and pre-ictal. For data preparation, we have taken interictal period as 4 hours before and after the seizure with non-overlapping, and and pre-ictal is taken as before 1 hour of seizure with 2-second overlapping. And for data pre-processing, we have done two steps. First, active bandpass filter with fifth order Butterworth filter was applied. Then MSTC was applied. This is the architecture that we have taken as reference. That is the multitask CNN model for easy classification. And this is the our proposed custom CNN framework. We have taken MFCC as input, then 7 convolution layers were used with 2 max pooling layers and 1 flatten layer and 3 dense layers. And after each layer, we have added normalization and leaky ReLU. This is the table that is showing the architectural details of our framework, and the total parameters were 5,33,095. This is the table that is showing the functions of each layer. Moving to the performance metrics. So performance metrics is very essential in deep learning to evaluate the model's accuracy and its reliability and effectiveness. After calculating the confusion matrix, with the help of the 4 main components, that is true positive, true negative, false positive, and false negative, we have calculated the accuracy, sensitivity, precision, Z-min, and F1 score. These are the experimental results for data 1, that is CSV MIT dataset. First graph is showing the training accuracy over epochs that is going towards 100%, near 100%, and the training loss over epochs. The next diagram is showing the training loss over epochs that is declining towards 0. And the right side of the diagram is showing the confusion matrix for CSV MIT dataset. And this is the graph that's showing the AUC ROC curve. And we got the AUC ROC curve that is 0.9095. And this is the table that showing the per class evaluation. For both the classes, we got accuracy 94.97. And for dataset 2, this is the graph.
Hello, Barka. Could you please speed up? You have only 1 minute left.
Yes, sure. This is the training accuracy graph, and this is the training loss graph. And the right side of the graph that is showing the confusion matrix for the CNI scalp easy dataset. And this is the ROC AUC curve for our framework, and we got the AUC that is 0.9706. And this is the table that is showing the per class accuracy for the dataset 2, and for both the datasets, for both the classes, we got 99.65 for this dataset. And we have compared the dataset with a few existing methods, and you can see we got accuracy 94.97, sensitivity 90.95, specificity 90.95, precision 88.43, z-min 90.79, and F1 score that is 89.63. For dataset 2, we got accuracy 99.65, sensitivity 96.51, specificity 96.51, precision 97.06, z-min 96.45, and F1 score 96.78. And for moving to the conclusion part, we have designed a 2D CNN to classify epileptic seizure from easy signals, and from the results, our framework demonstrated the robustness and effectiveness. So these are the differences, and this was all, and thank you.
Hello,
Ma'am, do you have any
congratulations to
questions?
your work, ma'am. So, from where you have collected the data?
Yes, ma'am.
Hello?
Yes, ma'am.
From where you have collected the data which you have presented here?
From PhysioNet, we have collected the datasets.
So, is it not the authentic data, right?
Sorry, ma'am.
Have you collaborated some medical institute or like medical college or some from your known?
No, ma'am.
I think you have collected data from website only, right?
Yes, ma'am. Only from website.
Okay. So you can try with that also, na?
Yes, ma'am.
Yes, you can collect data from any medical person, and after that you can compare for authenticity.
Yes. In future, ma'am, I will try.
Okay. Thank you.
Thank you, ma'am.
Thank you for presenting. I would like to call upon our next presenter,
Thank you.
Juhi Shah, to present the paper titled Bridging Technology and Ethics in Dialogue Systems, a Survey of Real World Challenges. Over to you.
Yes, ma'am. I'll share my presentation.
Yeah, sure.
Is this visible?
Yes, the screen is visible. You can start presenting.
Good afternoon, everyone. I'm Juhi Shah. The title of our survey paper is Bridging Technology and Ethics in Dialogue Systems, a survey of real-world challenges. This is the outline of this presentation. I'll begin with the motivation and then discuss application domains, key ethical challenges, real case studies, and then I'll present recommended approaches and conclude with future directions. Now, dialogue systems are also known as chatbots or conversational agents. They are basically computer programs that can communicate in natural language like Gujarati, Hindi, English, or any language that it is trained upon. They are widely used across customer service, personal assistance, education, and healthcare. Because of this rapid adoption of chatbots, the global market is projected to reach $46.6 billion by 2029. But around 40% of organizations have experienced privacy related incidents because of AI systems, including sensitive data leakage through chatbots. Uh, because dialogue systems are widely deployed and they handle such sensitive user information, studying them is essential to address the growing ethical risk. This diagram shows applications of dialogue systems. They are used across multiple domains such as healthcare, business, e-commerce, education, finance, travel, entertainment, and many more. These systems support tasks ranging from information retrieval and tutoring to medical assistance and user engagement. Now, because they operate in diverse contexts, the ethical impact of dialogue systems varies across domains. This table categorizes dialogue systems across different application domains and compares them based on interaction sensitivity and ethical sensitivity and ethical risk. Uh, Now, interaction sensitivity refers to how personal, private, or emotionally intense the interaction between the user and system is. Uh, for example, mental health chatbots has high interaction sensitivity than a basic weather chatbot. Now, ethical sensitivity refers to how serious the ethical consequences are if the system makes an error or behaves incorrectly. A healthcare chatbot has higher ethical sensitivity because incorrect advice can harm health, while a productivity assistant usually has a lower ethical sensitivity. So, interaction sensitivity focuses on what users share, while ethical sensitivity focus on what can go wrong and how harmful it can be. Uh, these are some ethical challenges faced by dialogue systems: privacy and data protection. Without any rigorous safeguards, when personal data is handled improperly, data could be shared, stolen, or misused. Bias and fairness. Now, bias in training data can result in unfair or discriminatory responses, particularly in education, hiring, and healthcare applications. Misinformation and trust. Uh, Misinformation is another major risk as incorrect advice can damage trust and cause real harm in critical domains like healthcare and law. Emotionally engaging chatbots may cause emotional reliance in users who share deeply personal thoughts. These are some case studies that have raised ethical dilemmas. The first one is the Cambridge Analytica scandal. This case shows how dialogue-based data collection can be misused at a large scale. So in 2018, it was found that Cambridge Analytica collected data from millions of Facebook users without their permission. They used survey-style chatbots to gather personal information, which was later used in 2016 US presidential elections. So this situation highlights how data collection via chatbots can be weaponizing to manipulate political opinions. The second case study is Amazon's recruitment bias. In 2018, Amazon abandoned its AI-based hiring tool because it showed gender bias. Uh, so basically, the system had been trained from resumes of men only, so it began penalizing resumes that included the word women. So this demonstrates how bias in training data can directly affect real-world decisions.
Hello, Juhi ma'am. There's a notification at the right corner of your screen. Can you please close it?
Sorry.
Okay,
Now
continue.
it's okay? Okay.
Yeah,
So
I
the
think
third case study is chatbots in the 2016 US presidential election. This case illustrates how dialogue systems can influence public opinion at a large scale. So, during the 2016 US presidential race, automated bots and fake social media profiles were used to spread false narratives and polarizing contents. So, these bots engaged with real users to influence opinions. The design made them seem so human, which made it difficult for users to identify if they were real person or not. So this underlines the danger of using dialogue systems to influence elections and need for better content oversight by platforms. VBOT and mental health. This case highlights both benefits and limits of dialogue systems in mental health care. VBOT offers cognitive behavioral therapy via chatbots to users needing emotional support. It provides mood tracking and weekly check-ins. So it is a very useful tool for mental health, but still this system cannot replace licensed therapists. So users may become overly reliant on it and miss critical face-to-face care. This raises ethical issues around boundaries of AI in health, and we need more clear guidance and human oversight. The fifth case study is replica and emotional dependency. A replica is designed to simulate close relationships. Users sometimes form strong emotional attachments to replica, which in some cases leads to over reliance and oversharing uh, for emotional support. Such dependency raises concerns about emotional manipulation and blurred boundaries between human and machine interactions. So, there is a need for transparency and moderation. Um, Now, ethical risk in dialogue systems can be addressed through technical, human, and policy-based approaches. Technical approaches focus on improving how systems are built and trained. It focuses on algorithmic fairness, fact-checking, privacy-preserving techniques. Uh, Whereas human-in-the-loop approaches insert human oversights at key points because human judgment is needed at many places. Now, policy and design interventions. So we need some government governing bodies or to impose some regulations or ethical guidelines uh, to uh, define where and how dialogue systems should be deployed. This table summarizes major ethical challenges and maps them to appropriate mitigation strategies. Now, some risks such as bias and misinformation can be reduced using technical solutions. Others, including emotional manipulation and deception, require human oversight and policy support. So the key message is that no single solution is sufficient for all ethical challenges. Some require technical, or some require combination of technical, human in the loop, and policy reinforcement. Conclusion and future directions. Dialogue systems have evolved from simple tools into socially influential agents. Ethical risks vary widely across application domains, and technical solutions alone are not enough. Responsible dialogue systems require ethically aware and contextually sensitive designs. So, future systems should more deeply integrate human in the loop mechanisms, especially in high risk domains. These are the references. Thank you.
Ma'am, do you have any questions? Hello, ma'am.
No questions from my side.
Okay, ma'am. Thank you for your presentation, Juhi ma'am. Now I would like to call upon our next
Thank you.
presenter, uh, Valeboina Shiv Prasad sir, to present his paper titled Fair Hiring in the Age of Multimodal AI, Bias Amplification, Mitigation Strategies, and Open Challenges. Over to you.
Yeah, good afternoon, everyone. I'm going to share the screen.
Yeah, you can share the screen and start presenting.
Okay. Is it visible?
No, your screen is not visible.
Okay, one second. I'm going to share this.
Yeah, it's visible now. You can
Yeah,
start presenting.
yeah. Good afternoon, everyone. Myself, Shiva Prasad. Um, Today, I'm going to present our paper titled as Fair Hiring in the Age of Multimodal AI, which gives bias amplification, mitigation strategies, and open challenges, authored by myself and my co-authors from the Department of Artificial Intelligence and Data Science from Chaitanya Bharati Institute of Technology, Hyderabad. So moving to the content, I'm going to give 8 different sections in this presentation. And the first one is introduction, where we see the rise of AI in recruitment. AI has transformed hiring through tools like using video interviews and resume shortlisting and screening through platforms. Modern systems using multimodal data like text, audio, video, and images to assess candidates holistically. I mean, overall, with an overall evaluation, which increases efficiency but also gives a risk. Well, instead of mitigating, it amplifies the historical human biases in the recruitment process. And one of them is multimodal bias challenge, which combines multiple data sources which has unique bias pathways. Like text may contain the gender based, voice may contain the accent, and the video may contain the appearance biased features during the recruitment process. These bias can actually propagate and accumulate during the decision making process for shortlisting or even evaluation process. So there is the need of fairness aware AI in the recruitment process, and our review actually covers 2019 to 2025 research to inform equitable, transparent, and adaptive systems. Moving to the literature's review, as you can see, there is a study named Examna platform, which actually uses a custom multimodal dataset and integrates automatic speech recognition with natural language processing and computer vision to assess transversal skills like communication and teamwork in the recruitment, which actually achieves 85% accuracy in skill evaluation, but there is a gap to give real-time bias correction mechanism, which include there is no cross-cultural validation with intersectional fairness into the platform. And moving to GAN counterfactual video analysis, which applies a GAN-based counterfactual generation to a video interview dataset to measure bias related to gender, accent, and even appearance too, which actually gives a 12% reduction in bias as a result. But there is only limited to video only analysis. I mean, there is no scope of having text or audio other than video. So it's not scalable for the real time use also. I mean, it's not for the interactive process. Moving to the next study, FAIR CV test, which actually uses 24,000 synthetic profiles to provide a standardized bias, which actually tests framework for recruitment process. This bias detected by the system is in 89% of tester systems, but only supports text and structured data, not audio or video. Does not account for temporal shifts in bias, and even it lacks in dynamic updating. Moving to the next study, um, casual fire data generator, which actually applies directed acyclic graphs DHs to the adult census data, which is which is about the income. I mean, they're earning to generate bias-free synthetic recruitment data, which improves fairness by 20% without accuracy loss, but requires significant casual expertise to implement. I mean, it needs the human feedback intimacy into the recruitment process, like human in the loop, but not yet adapted to multimodal inputs and lacks real-time deployment capability. Moving to late fusion fairness model, this actually uses a fair CV data DB dataset, which actually has late fusion of text, image, and structured data. I mean, instead of fusing early, it directly evaluates each path like text, audio, video separately, and then it fuses the result instead of the early one, which gives fairness better than the early fusion, but increases the system complexity and latency. Trade-offs between fairness and accuracy are not well quantified, and scalability remains a challenge because it's not well quantified for that system. Now, moving to the research gap analysis, there are 8 major research gaps for this, mentioned in this review. One of them is lack of unified multimodal fairness frameworks. Like there are current models which does fairness uh, per modality, like text separately the text, separating the text, separating the audio or the video, which not across the full recruitment pipeline, which leads to fragmented bias detection. And in further, there will be interventions uh, um, which is not mitigated properly. The next one is absence of real-time bias mitigation. Most systems are post-audit and lack interactive. This gives there is no real-time feedback for candidates and recruiters, preventing proactive fairness during the hiring process itself, which requires like a human in the loop auditing in the recruitment process. Moving to the third one, limited intersectional fairness metrics. Most metrics focus on single attributes like gender, but there are some overlapping identities which actually worsens marginalization because the model is trained on different attributes. Since seeing a single attribute may affect the fairness metrics. Moving to scalability versus fairness trade-offs. Implementing fairness at scale increases the computational cost, which makes the compromisation for the system efficiency if it requires real-time and faster results. And the next one is Western centric fairness standards. Research and regulations are predominantly Western, which actually lack adaptation to the diverse culture, legal, and ethical context globally. Uh, Moving to the next research gap, privacy complaint bias auditing. The GDPR, the laws which actually restrict access to attributes limiting bias assessment methods that require sensitive demographic data. And the next one is static view of evolving bias. Bias is always modeled as static, ignoring how labor market shifts and societal change affects fairness over time. I mean, the change over the time, changes in the time, the societal changes never affect the bias uh, in this process because it taken as a static instead of it may changes the dynamic throughout timeline. Moving to no standardized benchmarks. There are no common data sets or metrics or valid protocols for this. So it takes a comparative research and consistent fairness evaluation across the studies. As you can see, there are some notable incidents happened from 2015 to 2025, where several models have given shown the fairness. There is no fairness in the recruitment process. For example, Amazon ends AI-based screening tool for hiring finding bias in resume rankings only.
Hello, sir,
Yeah,
you've reached the 9-minute benchmark. So can you just speed up your presentation? You have one
yeah,
more
yeah,
minute left.
yeah.
Yeah,
Okay.
thank you.
Yeah, moving to dataset analysis. There are several datasets which contains like multimodal dataset containing resumes, video interviews, and audio, um, which actually helps to indicate synthetic bias triggers label protected attributes. But it actually lacks because it's not dynamic every time. It's considered as static. Moving to synthetic bias test beds. This actually has 24K profiles structured, which gives fair data generation and casual testing. But the main feature is bias-free synthetic data, which actually supports counterfactual fairness, but does not provide any multimodal procedure and requires casual expertise. And there is a tool called Examna, which gives custom-sized video, audio plus text which is used for integrated skill assessment, used for communication and teamwork evaluation. It's not publicly available, but also lacks cross-cultural validation. And moving to methodology analysis, whereas several techniques and trade-offs used in these methodologies are like bias detection approaches, like finding counterfactual fairness, like text how outcomes change if protected attributes, and bias mitigation techniques like pre-processing, in-processing, and post-processing, which are moves to fusion-specific strategies like late fusion versus early fusion. Late fusion gives better fairness than early fusion, but it increases the complexity and also the latency in the systems. And one of the best method or emerging method is human in the loop auditing, which gives him fairness perception and trust from the human side, which gives a recruiter feedback to correct bias in the real time. But there are the scalability issues subject to human bias only. And I want to summarize this. As you can see, multimodal AI improves hiring efficiency, but also amplifies the bias risk. Current fairness methods are fragmented, and post HOC and lack real-time and intersectional adaptation. Key gaps remain in unified framework, scalability, privacy-aware auditing, and standardized benchmarks. There are future research directions like moving forward, we can recommend like developing integrated multimodal fairness platforms, designing intersectional fairness metrics, building adaptive, culturally aware system like with regulations in the acts like European Union Artificial Intelligence Act, DPDP, Digital Personal Data Protection Act, etc. And also, we can promote standardized benchmarks and open data sets to provide fairness research in the future case, and to and we can actually explore hybrid methods that combines casual inference, federated learning, and human oversight. And these are my references for my review. And any questions?
Hello, sir. Nice work. Congratulations
Thank you.
for your work. No questions from my side.
Thank you.
Thank you
Thank
for
you.
presenting.
Yeah, I can.
I would like to now call upon the next presenter, Harsh Bhasin sir, to present his paper titled Handcrafted versus Deep Transfer Learning Features for EEG based detection of major depressive disorder. Over to you, sir.
హలో, ఇది టెక్నికల్ సెమినార్ ఏంటి?
So, good afternoon, all. Am I allowed to share the screen?
Yes, definitely, sir.
Ji. Thank you. So, good afternoon, all. So, this is my second paper in the same conference. Uh, we, as a group, work on depression detection on various modalities. So, this particular paper is for like detection of major depressive disorder using the EEG modality. So, before starting off with anything, I would like to mention 2 points. First is that we all understand that depression is problematic. Depression leads to suicides. Depression is an issue concerning the governments across the world. First point, and second point, technically, EEG is one of the most fascinating data to work on machine learning and deep learning models. So we have tried something. I would like to show it to you. So we will introduce the session. Like we'll introduce the problem, the effects of MDD, and the groups affected by MDD. We'll have a brief description of the state-of-the-art methods, the existing ML methods, the review table. Then we come to the dataset description and our model. So the point is that, as I told you, that depression is prevalent mental health disorder, and it's not just low mood and severe psychological and cognitive impairments. It is like it affects approximately 4% of the world population. It may lead to suicide, which is problematic. Now, the point is that we have reduced productivity. Reduced productivity also affects economics. So, depression is something which also affects economics. Depression is something, if you and me ignore depression, then we may have cognitive impairment. And cognitive impairment, people suffering from cognitive impairment, approximately 15% of those people converge to dementia, probably Alzheimer's. So it is problematic. You, any student of ours, any home member of ours should not ignore depression as such. So this is problematic. Now, the point is that we have various groups which are affected by depression. I mentioned earlier also that we have collected some data set. This particular data set, the paper which I am presenting, this particular model is run on a publicly available data set, though we have got some data set from Ram Manohar Lohia Hospital, Delhi also. So, what are the existing state-of-the-art methods? Now, we come to the technical part. Now, EEG, as I told you, is an extremely interesting data. It has various channels, it has temporal variations, there are frequency patterns. There's extremely interesting thing in each channel of EEG. So the point is that earlier people used to do conventional machine learning, deep learning methods. handcrafted feature-based methods. Then there were problems in the dataset generalizations, because if you see the depression paper using EEG, everyone is claiming that they are getting 99% accuracy. Most of you, like if you repeat those experiments, you will not get probably three-fourths of it. So this is this is a very, very genuine problem all of you must have faced while replicating the researchers. Now, the point is that every research should be grounded on either the technical part or the clinical part. That is what we have tried to do. So the point is that, as I told you, that there were handcrafted features. That some of the works which used handcrafted features, including wavelet transform, alpha power, theta symmetry, and so on and so forth. There were some of the works which focused on feature selection. Then like many works have used deep learning and machine learning models as black box. They give the data, get some output, and say that this is the output which we are getting. Okay, along with the various curves. So the people have also used LSTM. Why? Because at the end of the day, it's a temporal data. So it is variation of time. Again, so people have, as I told you, that people have claimed that they have got extremely good efficiency and accuracy, extremely good accuracy, but the works are neither reproducible nor generalizable. This is one of our problems. Now, what we have done is we have taken a publicly available data, and there are two interesting things in this data. One is that we have 34 and 30 subjects as MDD and healthy groups, and we have three experimental controls: eye closed, eye open, and tasks. So we have taken a standard 10-20 electrode placement data set. It was in the EDF format. So we have various channels, and our challenge was to there were two technical challenges. One was to extract feature from every channel. It should not be the case that an average of the alpha power of every channel should give us the output. Why? Because in that case, we'll not be able to backtrack from where we got the results. In EEG, if you are able to backtrack from where you got the results, it will be extremely interesting. Why? Because it will exactly tell you whether it was frontal temporal lobe or it was parietal lobe and so on and so forth. So you'll get the region of the brain. So that was something which we tried. Now, the point is that I told you that various models have failed at various places, generally in generalization. The model runs on one data set, it doesn't give any performance on the other data set. So that should not happen. So the point is that we tried something. What did we try? So the thing is that we have taken the EEG data set. And the point is that if we have, like, once we have taken the EEG data set, then we extracted features from every channel from three methods. So first was the handcrafted feature, the LSTM, the local binary pattern features. Second was CNN-based features. And the third, which we tried and didn't include in this paper, were frequency-based features. So as far as the conventional features are concerned, so some of the people, as I told you, have also given those EEG channels to the CNNs, got the features, concatenated those features, and saw the results. What we have done is we have also extracted the handcrafted feature from each channel, concatenated those features, combined them with the CNN-based features, and got the results. So the results, as you can see, we are not claiming that we are getting 90, 93, 94% accuracy, but the interesting part is that the accuracy is similar to F1 score, first point. And second point, we have tested it on two data sets. It is giving the similar accuracy. So one of the problems that I told you before beginning my slides was that if I'm getting some accuracy on one data set, the model doesn't work on the other data set. This is not what is happening in our data set. So the point is that I told you that we have got some data set from a hospital. We are running our algorithms on that data set. We are trying to get more data. Second point. Third point, we are trying to again, in EEG there are various bands. So there is some alpha band, there is a theta band. Alpha and theta bands are actually correlated to cognitive impairment, and cognitive impairment may indicate depression. So what we are trying to do right now is to correlate those exact features. The features extracted by the alpha band, the features extracted by the theta band, the TAR, the connectivity features, combine them all, combined with the handcrafted features of each channel along with the CNN feature of each channel to get a robust model. So this is what we are intending to do. We have already started the work. Thanks a lot. Any questions are most welcome. So, ma'am.
Ma'am, do you have any questions?
Nice work, Harish sir. Sorry, Harsh sir. And
Ji.
no questions from my side. Nicely
Thank you.
presented by. Thank
Thank you.
you.
Thank you. Ji, ji,
Thank you, sir, for presenting.
ji.
I would like to call upon our next presenter, Somesh Gadilkar sir, to present their paper titled Smart Civic Chain and AI and Blockchain-Based Platform for Transparent Public Grievance Redressal. Over to you.
Hello. Ma'am, am I audible?
Yes, you're audible. You can
Okay.
share the screen and
Very
start
good.
presenting.
Sure, ma'am, sure. I hope my screen is visible to
Yeah,
everyone.
it's visible. Yeah.
It's visible, right?
Yes, it's visible.
Okay. So, good afternoon, everyone. My name is Somesh Kadilkar. I'm the student of SICSR, Symbiosis International Deemed University. And today I'm going to present the paper which is on Smart Civic Chain, an AI and blockchain based platform for transparent public grievance redressal system. So in which we'll understand the recent problem people are facing. So we can see that in rapid urbanizations and population growth, there are so many problems related to the civic. So that it can be related to the pothole, it can be related to the broken street lights, it can be related to the broken bridge, and also garbage as well. So there are so many problems that people are facing, and it's not like there is no system or there is no complete system against that. So there is existing government system, but it is not that much trust. Like transparency is not there, accountability is not there. So people don't have that much trust on the system, and also it is not working that much properly that it should be. If people are getting, if citizens are registering the complaint, so it is not getting solved as early as possible. So this is the current issue in the this is the issue in current redressal system, grievance redressal systems. And if you talk about the observation and statistics, then 7,083 pothole complaints were registered in BMC in just two monsoon months in Mumbai. So it shows that how many so many problems are there related to the potholes only. Then in between June 2023 to October 2025, 27,634 garbage related complaints were registered through BMC WhatsApp helpline. Now, in Vadodara Municipal Corporation, 5,174 potholes during one monsoon season only occurred. So, in Mumbai, overall, if you talk about the overall complaint, then 1,15,000 complaints were registered for potholes or different like air pollution and drainage system as well. So and these shows that how important and how critical this issue is like, and it should be get resolved as early as possible. So there are some references also I have mentioned. These all statistics I got it from Times of India, and the clips also I have mentioned over there. So if you talk about the literature review, then there are already some research happen in this same category and same field. So research was done, but the problem is that the gap is that they have only explained about the some specific technology and technology and some specific problems only. So for example, Sharma ETAL. So they develop a digital grievance redressal system using NLP based complaint categorizations, highlighting the need for automation and transparency in public service delivery. So what they have developed is that
then BP is of normal. It can combine, it can easily choose that very important features, like critical features. That's why just converting fuzzy rule based to.
Hello. Do anyone have any question or like? Hello.
I think his mic was on by mistake. You can continue.
Okay. Thank you, ma'am.
Yeah.
So as I mentioned that Sharma IT also did the same research, but it was only related to one problem. They just feel that for large amount of data, there should be automation, there should be NLP, or there should be AI to that get that data. So they have introduced that technology. They have implemented that technology, and they have made the research according to that only. But what we have seen is that there are so many majority of problems over there, like transparency should be there, then trust, then accountability should be there, then automation should be there, then also duplicate issues should be or duplicate complaints are there. So to solve that, there should be duplicate like a detection system also should be there. So there are so many majority problems. So and all research, all authors are just did research on some specific category, some specific problems, and they have just solved that only. So there was a gap that, and for that we have introduced multiple technologies and to solve the majority of the problems that is in current grievance redressal system. So if you talk about the issues faced by citizens, then as I have mentioned that poor road conditions and potholes are the biggest issue in India nowadays. Then irregular garbage collection. There is like employees for that, but they are not like organized, and there is no or like properly work is going on in garbage collection. Then frequent water supply disruptions and shortage of clean drinking water. This is also very important issue because so many people, so many states or so many cities doesn't have the clean water, and it only spread the diseases, and it is very important that we should have the clean drinking water. Then blockage drainage systems. So we know that during monsoon seasons we have seen this so many problems, like there is blocked in drainage systems, and because of that it spreads so many diseases in the society. And also the faulty or non-functional street lights. This is also very important issue, because now, like if there is no street lights are working properly, then it is like security of women and like girls as well. So for night time there should be functional street lights as well for safety purpose. So it is happening because of lack of timely response and accountability from civic authorities. So these issues are there. People are complaining against them, but still, because of lack of accountability and from civic authorities, it is not getting solved. So if we talk about the roles of emerging technologies in civic governance, so what we have done is that, as I have mentioned, that three technologies we have mentioned over there, and with that technology we have tried to cover all problems, all the related to all major problems related to the civic issues. So first is AI. So in AI, what AI will do, once that platform got the input from citizens that complaint is getting registered, then AI will automate complaint, check the authenticity and verification, then classification and resolution. So according to the categories, or AI will classify that complaint and will check the validation or and the authenticity of the complaint. After that, machine learning. Then machine learning will prioritize the issues according to the urgency level. Some issues are very urgent, it should be solved within 24 hours, but some are not that much urgent. So according to the urgency level, ML will prioritize, and it will happen based on the previous data or the data that we have given to the ML. Then it will predict the high risk problems areas. Also there are some problems are having high risk. For example, uh, bridge is broken, or there is huge pothole happen on the occurred in the into the road. So it is very critical problem, so it should be solved within 24 hours or within like 72 hours. So ML will prioritize that. Then there is blockchain. So the major problem in the current system is that trust and reliability. So there is no trust and also accountability. There is no accountability for that. So to solve that problem, what we have done is that we have understand that blockchain is very important because it is immutable. We cannot edit that, we cannot change that, and it is very safe and secure as well. So it will ensure security and immutability and transparent storage and of grievance records. So it will store the record properly and will give transparency to the citizens, so that they can trust the process, they can trust the platform. Then geotagging. So geotagging is also one of the technology. So it is like capturing the accurate issue locations for faster response and efficient resource allocation. So geotagging is used to get the exact data coordinates, and through that only like AI, ML, and blockchain can verify the data is it accurate or not. Now we'll talk about the model steps of this smart civic chain. So first, it is like complaint submission. So for once citizens have the dashboard, so if citizens have the app interface. Through that, they can raise the complaint, and in the complaint form of text, images, videos, and geotag locations as well. So after that, data validation part will be there. So AI will verify the authenticity and relevance of submitted data. Then issue classification. Then AI will classify the issues according to the different categories like potholes, roads, street lights, garbage. So these are all different categories of civic issues. So AI will categorize that issues automatically. Then priority assignment. Then ML will understand which issue is very critical, which issue should be solved in urgent basis. So according to that urgency, ML will classify the priority. And then duplicate detection. We all know that there are 25,000 complaints, but some complaints might have for like some particular issue only. So for example, if there is one pothole, so for that pothole multiple citizens can apply the issue, apply the complaint. So it will consider as multiple complaints, so it should not happen. That's why ML will understand the issues, duplicate issues, and those who are like for duplicate issues, they will consider as one issue only, one complaint only, but a complaint and multiple tickets or maybe multiple count of numbers. So it will so ML will identify that, and after that blockchain logging. So then once AI and ML's part is over, then blockchain will understand that data from ML and then verify complaints are stored immutability with timestamp and location. So each complaint have some timestamp when it is getting raised and the location coordinates through geotagging. So that based on that, blockchain will create the block or the ledger, and it will be stored to that block. Then department allocation. So but according to the complaint, according to the specific issue, who is responsible for that complaint, it will directly goes to the that authority person, and that person will get notification that you have to solve that issue. It is related to that category and that department. Then issue resolution. So once the issue is getting resolved, then that authorized person have to upload the after resolve issues images and videos to the.
Hello, sir.
Yes.
You have reached the 9-minute mark, so you have 1 more minute left. Can you please speed up your presentation?
Sure, ma'am, sure. Then real-time
Yeah, thank
tracking
you.
sure, ma'am, sure. Thank you. Then real-time tracking and feedback improvement. So feedback is, we all know that to make our system more improve our system performance. So if you talk about the model diagram, then there is user, civic connect app interface, and then three technologies. As I mentioned, it is covered over here. Then the government panel also there. So it is only accessible for government and public dashboard. So it will be accessible for everyone. So everyone can track the status of the complaint, and they can see the who is responsible, who is working on that, and it is solved, resolved or not. And then feedback section. So this is the working architecture of the overview: user intersection layer, AI processing layer, machine learning layer, blockchain logging layer, government dashboard, public dashboard, and feedback layer. As I have mentioned in this diagram, it is like user interface, technologies, government panel, and public dashboard. So these are the model diagram, and this is the explanation of model diagram. Then there is a conclusion part. So as we know that what we have done is that we have integrated three technologies: AI, ML, and blockchain, and also geotagging to modernize the public grievance redressal system by automating verification, prioritizations, tracking, improve efficiency, and reduce manual intervention. And blockchain will ensure the transparency, accountability, and trust through immutable grievance records. So this will process the strengthen citizens government engagement and support smart governance. This is the impact will happen to the society. And then if we talk about the practical implications of this project, is that then it can be implicated by municipal corporation for faster and transparent complaint handling. Then it will help authorities prioritize critical civic issues using data driven decision making. Then it will reduce duplicate complaints and administrative workload through ML. Then it will improve public trust through real time tracking and accountability. So these are the practical implications. Now we'll talk about the future scope of this project. So future scope, there are two future scope as of now I have understand. One is like IoT integration. If we integrate the IoT and if we put the IoT devices in the all city, then there is no need to raise complaint through citizens. So we can direct IoT sensors can directly sense the issue and they can immediately raise the complaint by their own, and it will be get resolved as early as possible. So time, we can save that time. And also like after some certain years we'll get excess amount of data, and through that data we can understand that which type of complaints are coming frequently, or there is pattern in complaints. For example, in monsoon seasons, there is like in this area every monsoon season there are complaints are getting raised. So based on that we can do it predictive analytics through ML, and we can understand that okay, these problems might can come, and how what can be do to solve that issue in the future. So this can be happen through ML, and these are the future scope of this project. And thank you for giving me opportunity to present my project, my paper, and now I'm ready to answer the questions.
Thank you for presenting, sir. Ma'am, do you have any questions?
No questions from my side, and nice field work done from you, sir. Thank you.
Thank you so much, ma'am.
Thank you for presenting. Now I'd like to call upon our next presenter, Meera Thappar Khanna ma'am, to present her paper titled Unveiling Deep Learning and Ensemble Learning for Bitcoin Price Trend Analysis. Over to you, ma'am.
Thank you, ma'am. Good afternoon, everyone. Let me share my screen. Share screen. Yes. So I hope it is visible. I am audible.
Yes, ma'am, the screen is visible and you can start presenting.
Okay. Thank you, ma'am. So good afternoon, everyone. I'm Dr. Meera Thapar Khanna along with Dr. Shilpa Pandey. So I'll present a work on unveiling deep learning and ensemble learning for Bitcoin price trend analysis. So these are the presentation outline. So in this presentation, I'll discuss a comparative study on cryptocurrency trend prediction using deep learning and ensemble learning models that focus on both predictive accuracy as well as the computational efficiency across short and long-term forecasting horizons. So as we know, cryptocurrency is a virtual currency or a digital currency secured by cryptography. It is mainly used as a medium of exchange without any third party involvement, such as banks, etc. So the main issue with and this is the main cryptocurrency is very important from the like traders point of view and for the economy of any country. So cryptocurrency prices fluctuate rapidly and are difficult to predict due to their non-linear behavior. So there are many studies that address short-term prediction, but long-term prediction and especially the computational feasibility remains unexplored. That is the main motivation for this work. So here the goal is not only to improve prediction accuracy, but also to understand the trade-offs between accuracy and computational cost, especially for the real-time forecasting applications. So these are the main objectives. We have forecast the Bitcoin prices from 7 days to 120 days, conduct a comparative analysis between both deep learning and ensemble learning methods to forecast Bitcoin prices, evaluate, these are the models that we have involved in the study, and analyze the computational expenses associated with the trends. So this is the proposed methodology. So here we have selected the data and then pre-process the data, model training, then forecasting, and then the analysis of the results. So here we have considered multiple forecasting horizons that were evaluated to analyze how model performance changes as prediction length increases. So primarily we have used RMSE to measure the accuracy as an accuracy metric along with the computational measurements. So starting with the dataset description. So this is the link for the dataset. We have used the Yahoo Finance Bitcoin USD dataset. So these are the main attributes included in the dataset. These features are considered important as they provide the comprehensive information about market behavior and price movements over time. So here we have considered the main features like high, low, open and close prices that are the primary components of daily market data spanning from, we have taken the data from September 2014 to March 2024. So here we have left out these two descriptors, adjusted close and volume, and the reason behind to leave this is like this adjusted close feature is the values in this is almost identical to those of the high attribute we have as we have analyzed the data set. So it will be redundant for training the model using this additional feature also. And for the reason to drop not considering this volume attribute is it arises from the potential for the market manipulation, because sometimes there have false trading volumes may be reported to create a misleading impression of market activity or liquidity. So that's why we have considered the above parameters, above features for the model training. Okay. So next is the pre-processing step. So for data pre-processing, we have used data formatting and data normalization. For data formatting means we have taken the data column as a date column as well. So to format this as an object type, we have converted it into a indexing format to sort for the chronological sorting and filtering based on the time periods. And second one is the data normalization. Here we have used the min-max scaling technique to normalize the data to set the range between 0 and 1. So these are the models, forecasting models selected. So we have selected the model as to fit the that are fit according to the inherent nonlinear relationship and the time lag forms between the dependent and independent variables within the data. So basically this LSTM by LSTM is well suited for this task as it captures long-term and bidirectional temporal dependencies, like it takes over the window, the past data and the present data as well to enable the model for complex nonlinear price dynamics. And random forest, on the other hand, basically in ensemble learning models. We have taken random forest, XGBoost, and gradient boost because it handles fluctuation effectively by aggregating multiple decision trees, making it robust to noise and sudden price fluctuations while maintaining low inference latency. So the initially the for the results and discussion, these are the time periods over which we have computed the forecasting. This is the data set. These are the mean matrices that we have considered for the evaluation, and evaluation is for training time and prediction latency. So initially the data was divided into input and output variables for model building, and the close parameter is considered as the target parameter for prediction. So here, from the performance evaluation, you can see that in deep learning models, as we can see from the table, the LSTM achieves lowest RMSE value. It captures both the dependencies, so it predicts well. And out of the ensemble models, this random forest outperforms other models, and it demonstrates strong generalization on the data set. These are some of the visualization of the results. So here we have presented these graphs for the BioLSTM from 7 to 120 days prediction. So this blue line indicates the prediction, and red is for the forecasting for different time periods. So we have analyzed the computational efficiency of all the models also. This graph shows the prediction time in seconds, and these are the models using deep learning and the ensemble learning models. BioLSTM performs well for the prediction accuracy, but it takes higher training and inference time, as it is indicated from the graph. And among this, random forest turns out to be faster for training and significant lower inference latency. So it is the best balance between accuracy and efficiency. So we can say that if there is a accuracy and efficiency trade-off is there, so for the accuracy purpose, we can use the BioLSTM model. But if we go with the real-time prediction, we want the fast inference of the results. So we need the random forest model. So it depends on the choice of the model, depends on the parameters that is required. Okay. So basically the conclusion is the study provides a comprehensive comparison of forecasting models, and it supports practical deployment decisions for offline BioLSTM for offline high accuracy model, and for real-time predictions the random forest can be used, and these results are valuable for traders, financial analysts, and real-time cryptocurrency platforms. So certain we have in this work we have considered the Bitcoin, so we can incorporate another cryptocurrencies for the prediction also, or even other than this we can incorporate the sentiment analysis and on-chain metrics for the better forecasting of the prices, and we can try with the hybrid models also that contains both deep learning plus ensemble learning methods. So these are few references. So, thank you. So thank you everyone, and I'm ready to take the questions.
Thank you for presenting, ma'am. Nidhi ma'am, do you have any questions?
No, ma'am, no questions from sir.
Okay. Thank you, ma'am, for presenting. I would now like to call upon our next
Thank you.
presenter, Raj Singh sir, to present his paper titled Wildfire Detection Using Satellite Imagery and Synthetic Thermal Images. Over to you, sir.
Hello. Yeah, I wanted to ask that my whole group is present right now. Like we three are there, so can we have like divided our parts. Can we just do that?
Can you repeat?
Yeah, so we three authors are here right now. So we have like divided the presentation. So could we like present together right now? Like all three of us.
Uh, uh, I think that's fine. You can present.
Yeah, thank you.
You can start sharing. Yeah.
Yeah.
So, good afternoon, everyone. I'm Prachi, and I'm here today with my co-authors, Raj Singh and Sehajveer Singh. and we'll be presenting a work titled Wildfire Detection Using Satellite Imagery and Synthetic Thermal Images. Now, this work addresses the challenge of early wildfire detection using vision-based systems with a focus on improving robustness while avoiding the high cost. So the motivation and the problem statement for this topic was that wildfires remain one of the most destructive natural disasters, causing a large-scale ecological damage, economic loss, and threats to human life. Early detection is critical, yet most existing computer vision systems rely purely on RGB imagery, which degrades significantly in the presence of smoke, haze, low illumination, or occlusions. Now, thermal imaging can overcome these challenges, but thermal image sensors are pretty expensive and power intensive as well. Now, our research objective was based on, there were like four main objectives. So the first one was to design a cost-effective wildfire detection framework. Second, to integrate RGB imagery with synthetic thermal information. Third, to improve robustness under a visually adverse condition such as smoke and low light. And finally, to maintain real-time inference performance suitability for edge and UAV-based deployments. Now, related traditional fire detection approaches relied on color thresholds and handcrafted features, which are highly sensitive to environmental variations. And more recent CNN-based RGB models improve performance, but still struggle in complex scenes and often produces false positives due to the reflections or like sunlight. Multimodal RGB thermal systems address these issues effectively, but they require dual sensors, which is very expensive. Therefore, the key gap is the absence of a low cost thermal aware fire detection solution that does not rely on thermal hardware.
So this slide illustrates the overall system workflow. A four-channel input image is first passed on into the network, where both visual features such as edges and smoke patterns and thermal features such as heat intensity and hotspots are learned. Then these features are processed through convolution layers and residual blocks, allowing multi-scale feature extraction. At deeper levels, the model captures high-level semantic features by integrating visual and thermal information, which improves robustness in challenging conditions like low lighting, cloud cover, and visually ambiguous scenes. Finally, after global average cooling, a binary classification layer produces the final output indicating the presence or absence of wildfire. Uh, in the data set and pre-processing, we use the plain vision data set, which contains approximately 12,000 images representing both fire and non-fire scenarios. The dataset includes a wide range of environmental conditions, which help the model learn robust wildfire patterns. Because real thermal satellite data is limited, we generated a synthetic thermal channel from RGB images. This additional channel highlights heat intensive regions and provides useful information for early wildfire detection. The dataset was divided into training, validation, and test sets with balanced class distribution. We also applied data augmentation techniques such as rotation and scaling to improve generalization and reduce overfitting. Moving on to the model architecture, we propose a four-channel ResNet 34 model where the input consists of standard RGB channels along with a synthetic thermal channel. This enables the network to process both visual and thermal information simultaneously. An early fusion strategy is used, meaning all four channels are combined at the input layer. This is particularly effective for wildfire detection, as thermal anomalies often appear before strong visual indicators, such as visible flames or dense smoke. ResNet 34 was selected due to its balance between computational efficiency and feature representation capability, and pre-trained weights were used to achieve faster convergence.
So the main thing, result and the parameters, we'll see that we evaluated our model using accuracy, precision, recall, F1 score, which are important for safety critical application. Our proposed ResNet 34 achieves an accuracy of 95.3, outperforming both RGB only ResNet and efficient B0, sorry. This our model is basically has a 3.8% improvement over the RGB baseline, demonstrating the effectiveness of synthetic thermal fusion. The gain is achieved with only marginal increase in the model parameters. There's also this confusion matrix. Okay, next we'll see the ablation and visual analysis. We see that the performance gain is meaningful with conductor and illusionary. When thermal channel is replaced with random noise or HSV only information, performance degrades, confirming that improvement is due to heat-inspired information rather than additional channels. Great cam visualization show that the proposed model focuses on flame and smoke regions, while RGB only models often attend to background reflections. This highlights improved robustness and the reduced false positives. Now, some applications of a model and some use cases would be that a wide range of real-world application, including satellite-based wildfire monitoring, UAV surveillance, forest watchtowers, and internet IoT-enabled early warning systems. The system achieves a real-time interference at approximately 46 frames per second on RTX 3060, making it a viable for edge deployment. Some limitations and future work would be that while the proposed method is effective, domain adoption remains a challenge across different terrains and climates. The current system performs binary fire classification. Future work includes incorporating real thermal imagery, extending the framework to multi-class fire severity reduction, integrating attention mechanisms, deploying model on embedded edge devices such as distant platforms. Now, while concluding, I would say that we presented a cost-effective, eliminates the need for thermal hardware. Our approach achieves high accuracy while maintaining real-time performance, making it suitable for large-scale and edge-based wildfire monitoring system. Um, and the practical deployment is also, I think, very good. Okay, thank you.
Thank you for your presentation, sir. Ma'am, do you have any questions?
Nice presentation and nice work. So, just do some hardware work.
Okay, yes, ma'am.
This is my suggestion, and get some real-time results.
Okay, yes, ma'am.
Thank you.
Thank you, ma'am.
Yeah, thank you for presenting. So as we have finished all our presentations for today, I would like to give the closing remarks. Let's share the screen. So I would sincerely like to thank all our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 10th version and all the previous 9 versions of the conference. We will be happy to have you in the 11th version in 2027 as well. All the presenters will be getting their digital certificates through email within 2 working days. The publications will be live within 7 to 8 months. Kindly cooperate with the team of SMARTCOM 2026. I also thank our session chair, Dr. Nidhi Tiwari, for chairing the session. This is a token of appreciation to the chair on behalf of Team SMARTCOM 2026 and Global Knowledge Research Foundation and partners. Thank you for your valuable presence, ma'am. Before finally ending the session, I would request all the participants and the session chair to just on their cameras for a quick snapshot.
Thank you, ma'am.
Thank you, ma'am.
Yeah, thank you, ma'am. Thank you for your presence. Can you all switch on your cameras? Yeah. Thank you. I'll just take a screenshot. Yes, so I've taken the snapshot. I'd like to end the session now, and you may leave the session. Thank you all. Stay safe, take care. Thank you.
Thank you so much, ma'am.